Hello everyone, welcome to Yourpedia Education. So today we are going to discuss the solution of past paper which is taken by the BEL in the month of May, right? We are discussing throughout the detailed solution of this paper, right? Basically this time if I'm talking about this paper, this is completely theoretical paper, right? Last time if I'm comparing this exam with the last time they put some numerical question, but this time this is completely theoretical and conceptual paper, you can say, right? Okay, let's start with the first question. How does the binary number system contribute to error detection in digital communication system? See, basically if I am talking about digital communication system, in digital communication we generally transmitting 0 1 0 1 like that, right? And we are transmitting a you can say the bit of a string we transmitting. So basically to detect the error or correct the error in digital communication system, or you can say the bit of string, so what we can do, we can use the parity bit. We assign a parity bit, we give the parity bit like even parity or odd parity. According to that we can check the error, right? So what will be the answer? By using parity bit to detect a single bit error. So basically in digital communication we are using the parity bit to detect the error. And one more thing, the parity bit can only detect single bit error, right? If multiple bit error, then it cannot be detected by using the parity bit, right? Okay. Which Boolean law is represented by the equation A into B plus C, which is equals to AB plus A dot C? So basically this is called distributive law. Distributive law means what? When you are multiplying A into B plus C, that will be represented as A into B plus B into C. See, same thing will happen in Boolean algebra. When we are talking about the Boolean algebra, this AND operation is equivalent to the multiplication, this OR operation is equivalent to the addition. So what we can say, this is the similar to the distributive law, right? So answer will be C for this one. Next is, which of the following step is essential to minimize a Boolean function using K-map? Whenever you are using the K-map, you are minimizing a Boolean function using K-map. What we can do? We are making a group, right? We are making a group in the order of 2 to the power, right? We are making a group. First we are trying to make a group of 16 if possible, then we go for 8, then we go for 4, then we go for the pairs. If the pair is not possible, then we will take the variable single, right? So plotting the mean terms in the function into the K-map and grouping adjacent one into the power of 2, that is the correct answer for this one. So we are plotting the mean terms, right? When you are making a K-map, you make the first, you can make a truth table for that one. In the truth table where your output is 1, that output is 1 representing this mean terms, and according to that mean terms we fill the K-map and we make the grouping, right? We make a group of 4, group of 8, group of 16 in 2 to the power. So answer will be A. The control engineer design a lag lead compensator where the poles are S is equals to minus B divided by T1 and minus 1 upon beta T2, where 0 is at minus 1 upon T1 minus 1 upon T2. So basically if I draw the pole 0 plot, the pole 0 plot of a lag means the first thing what you're coming to mind, lag means the pole is dominating then a 0. Whenever you go for lead compensator, because it is first lag then lead, it means then we will have the 0 and pole. So this should be the pole 0 location of a lag lead compensator, and it is given to you that these two things, the poles are, this one is a pole, this one is a pole. So it means if I am taking this one as a minus 1 upon beta T2, right? Another one is minus 1 upon T2, and this one is a the pole, yeah, this one is a minus beta upon T1, and this is minus 1 upon T1. So what we can say? Yeah, this should be here and this should be here. So it means beta should be greater than 5. right? That then only it is possible. If beta is less than 1, then opposite thing will happen and it will not work like a lag lead compensator, right? Okay. In a gray code to binary converter, how is the most significant bit of the binary coded decimal? See, basically whenever you are doing the gray to binary converters, you are having a gray code here, like let us take Z3, Z2, G1, Z0. So G3 is directly written as B3. So these two bits are same. Then we will do the XOR of other bits and to get the next bit. So what will the complement of most significant bit, that is not correct, it equals to the most significant bit of the gray code as a input. So answer is B for this one. Okay. How does the triggering mechanism differ between the latch and flip flops? See, latch generally level triggered and flip flops are generally as triggered, right? Latch are level triggered while flip flop are as triggered. Answer is C. That is the basic difference between latch and flip flop. Which of the following is primary advantage of using Mealy machine over Moore machine? See, if I am talking about the Mealy machine over Moore machine, so Mealy machine will have the fewer states. States are less in Mealy machine as compared to Moore machine. Moore machine has one extra state to count the state of state machine. And one more thing, the mid transitions are available in Mealy machines instead of Moore machine. So answer will be B. Yeah. Which of the following is best describe a situation where a bidirectional shift register would be preferred over a unidirectional? Unidirectional means which is shifting the data only in one direction. Unidirectional. Bidirectional means you can shift the data left side as well as the right side at the same time, right? That is called as bidirectional shift register. See, bidirectional shift register, yeah, shift the data both the way or rotate the data, you can say. It can rotate the data, right? Answer will be B. Which of the following is a common application of a voltage control oscillator? Basically, a voltage control oscillator is generally used to generate the signals, right? Signal of in frequency synthesizer. Generally, we are using it is in phase lock loop, right? Where we generally generate the frequency with the help of this VCO. So answer will be signal generation in frequency synthesizer. What element are included in frequency spectrum of an AM signal produced by a sinusoidal modulating signal? Whenever you are having a sinusoidal modulated signal, then its frequency component basically what will be? If I am drawing a spectrum, the carrier frequency component is there, then carrier plus FM, FC plus FM, then FC minus FM. Right. So we are having, this is called carrier frequency component and these two components are called as sidebands. Right. So what will be the answer? The carrier and the sidebands. The answer will be B for this one. Yeah. A team is testing various material that are used in electronics device. Okay. Team choose one of the material having resistivity range of 50 ohm centimeter. Which type of material? See, this material is generally semiconductor material. See, basically you can see the range of here. Conductor have very low resistivity, 10 raised to power minus 8 to 10 raised to power minus 4 ohm centimeter. When we come out to be semiconductor, 10 raised to power minus 4 to 10 raised to power 8, and when you come out to be insulator, that will be 10 raised to power 8 to 10 raised to power 18. So basically he is choosing for 50 ohm centimeter, that should be a semiconductor, right? If we are talking about the you can say the resistivity of that one. A semiconductor based current sensor is used to detect a small variation in electrical current in microchips, right? A total current density in semiconductor material is to be measured. What is the total current density in the semiconductor material? Whenever we are talking about semiconductor material, inside the semiconductor there are two types of current. Inside the metals or inside the conductor there is only one type of current, that is drift current. If we talk about the semiconductor, there are two types of current, diffusion current as well as the drift current. So what will be the answer? Diffusion plus drift current, right? Consider a photodiode P plus I PN plus configuration. This is construction is similar to PIN diode, right? Containing two heavily doped. There are two heavily doped, P plus and N plus are heavily doped and two lightly doped region. lightly doped are insulating and P region. This in the avalanche photodiode APD, right? Which of the following are the heavily and lightly region in the device? See, basically what you are seeing here, this is P plus is heavily, N plus is heavily, and these two regions are lightly doped here. So answer will be D. P plus and N plus are heavily doped region, whereas I and P are lightly doped region. Yeah, next. For fabrication, yeah, this is most important thing. This time they asked the question from the VLSI where we are fabricating the CMOS inverters. In CMOS inverter, we generally fabricate the PMOS and NMOS on the single chip, but we are providing the isolation between them, right? So fabrication of integrated IC circuit, the oxidation method should be chosen to achieve the faster oxidation rate to create a thick SiO2 layer exceeding 1 mm, which accept a higher density of interface state. That will be this oxidation is wet oxidation. Dry oxidation has very less thickness, but wet oxidation has a very high thickness, up to 1 micrometer. It can work, right? In a dual valve process or twin tube process, during step 9, that is ionic implantation is performed to dope the source and the drain region of the PMOS and NMOS transistor. Which of the following is formed as a result of ionic implantation? So basically, whenever you do the ionic implantation means we are doing the doping. So by doing the doping, we are forming a P plus polysilicon gate in NMOS and N plus polysilicon gate in PMOS, right? So what we are doing, you can watch one video I already made on this dual valve process, in which I taught you that why we are making a polysilicon gate onto that one, right? So basically this 9th step is performing by using the ionic implantation. We are making a polysilicon gate on that one, right? In PMOS, NMOS we are making P plus, and in NMOS we are generally making N plus polysilicon gate there. Okay. The fabrication of a semiconductor device using dual valve process or twin tube process, the first step involves the deposition a thin layer of SiO2 on the p-type substrate surface with a lightly doped p epitaxial layer. What is the purpose of thin SiO2 layer deposit on the first step of dual valve and twin tube process? It is served as a pad oxide for that one. I already discussed that thing. This is called as pad oxide. A small signal equivalent circuit of a diode, what is primary parameter that determine the small signal resistance of the diode? If I am talking about the small signal resistance of the diode, that will be neta Vt over Id. That is the small signal resistance of the diode. That will be defined by the thermal voltage and the diode DC current. So answer will be P here. What is the primary function of a tank circuit in a sinusoidal amplifier such as Colpit oscillator? Whenever we are talking about the tank circuit is generally used to select the frequency. Let's take you are making a 1 megahertz oscillator, then that 1 megahertz frequency can be selected by using the tank circuit. So answer, select the frequency of oscillation. That will be the main use of that one. Okay, next. What is the purpose of Zener diode in a voltage reference circuit? Mainly the Zener diode is provide the voltage stabilization, right? You can say it is work as a voltage regulator inside any circuit. So what will be that? It provide a stable reference voltage by operating in reverse breakdown. Yeah, one more thing, your Zener diode is working in the reverse direction to regulate the current. No, Zener diode is not regulating the current. Zener diode will regulate the voltage. Remember that thing. Okay. Why is the transconductance of a MOSFET amplifier considered a key parameter? Basically, whenever we are talking about this GM, that is change in ID over change in VGS when your VDS is constant, right? So what is the transconductance of a considered a key parameter? It is defined as the ratio of change in output current to the corresponding change in input current, right? That's why. at low frequency, what caused the gain of a BJT amplifier decrease? See, basically whenever we are talking as a BJT amplifier, the amplifier frequency spectrum is like this, gain frequency. So this portion is called as mid-band gain, mid-band gain, right? Mid-band region, you can say. In this one, the gain of this amplifier is almost constant. Below this frequency, the gain will decrease. Above this frequency, this is called higher cutoff frequency. This is called lower cutoff frequency. So below this one, our gain is also decreasing. High above this one, the gain is also decreasing. So the main reason at lower frequency, the gain is decreasing due to coupling and bypass capacitor inside the amplifier. At high frequency, the gain will be decreasing due to junction capacitance of that amplifier, right? So what will be the answer? The coupling and bypass capacitance, right? He bring two questions from this same concept. If you know these things, you can mark, easily score 2 marks from this one, right? Next, in the MOSFET amplifier, what is the primary region of upper cutoff frequency? See, that's the same thing. At upper cutoff frequency, what we consider the junction capacitance, and we can junction capacitance of the MOSFETs, and otherwise other thing is that the Miller effect in the amplifier. Whenever you are having the capacitance, that will be Millerized and it will be go at the low frequency at high frequency. So answer should be the Miller effect in the amplifier, but there may be the answer is junction capacitance of the MOSFET. Both the answers are correct, right? But Miller effect is dominating, so answer should be B. What is the primary advantage of a differential amplifier over a single stage amplifier? See, whenever you are having a differential amplifier, it can amplify the difference, you can say that it can amplify the difference of two input, right? That's why it is called as differential amplifier. So generally it will reject the noise. So what we can do, we give the signal at one terminal, and at the other terminal we generally open that means that signal receiving the noise. When you are difference, we are taking the difference, the noise will cancel out and you are only having the signal, right? And you can amplify that signal by using the differential amplifier. So basically it will improve the noise rejection, right? Improve the noise rejection generally, the differential amplifier. Why does the gain of BJT amplifier reduce at high frequency? That will be due to parasitic capacitance and transistor transient time, right? Parasitic capacitance is the main region. Parasitic means junction capacitance is the main region here. 3 questions on the same concept, you can say. Which type of VCO is typically used in electronics beeper, that is relaxation oscillator is used in that one. Okay. What is the key advantage of active filter over passive filter? See, basically whenever we are talking about the active filter, okay, let's read. Low cost and simplicity. No, active filters have, you can say, high cost because they are using the active element like transistor, MOSFET, or you can say the op-amp also, right? And simplicity is not there. Provide amplification of the filter signal, right? Limit frequency range, no. Ability to provide gain and precision control over filter characteristic, that will be the answer. Higher power consumption, no. Power consumption is not that much higher. So the main reason is ability to provide the gain and precise control over a filter characteristics. That will be the answer for this question. What is the primary purpose of a sinusoidal amplifier in electronic circuit? What is the main purpose? Primary purpose of a sinusoidal amplifier in electronic circuit, that will be to provide a sinusoidal signal with a minimal harmonic distortion. That will be the answer. Okay, which op-amp configuration is commonly used as a voltage follower to provide a high input impedance and low output impedance, that is non-inverting amplifier? Okay. What is the purpose of modulation feature in the function generator? See, basically whenever we are talking about modulation is generally what? Changing of frequency. So whenever we are talking about that, increase the range of frequency of generator to improve the signal to noise ratio, no. To generate a different waveform with wide range of frequency, that is the main purpose of modulation, right? In which mode of operation does 555 timer continuously generate a square wave without requiring an external trigger. The main three modes are generally we are having, that is astable mode, that free running oscillator, one shot pulse and flip flop behavior, right? Whenever we are a bistable mode generally has a flip flop, right, behavior. It means it is having two stable state. When we are talking about monostable mode, monostable is one short pulse generator. It means it will generate the pulse and goes down. And free running oscillator, that is astable multivibrator. So if you want to generate a continuous square wave without any external, then you should use that in the astable multivibrator mode, right? Next thing. Okay, in a power supply, what is the effect of increasing the value of filter capacitance? The main thing is ripple voltage at output should be decreased. What does the integral of a power spectral density at overall frequency represents? When you integrate the power spectral density from minus infinity to infinity, Sxf d of f, that will give you the power of that signal, average power, right? So total energy of that signal, the average power, the signal average power, right? The maximum frequency of a baseband AM signal is FM. How much bandwidth it will need to overall send the modulated signal? See, whenever we are talking about the AM signal, the frequency is twice of the maximum frequency of the massive signal. So twice of FM will be the answer. Which of the following best characterized a narrow band FM signal? See, in case of narrow band FM, the modulation index should be less than 1. The beta will be less than 1. That this is called as narrow band FM. Which simple form of digital amplitude modulation is commonly used in transmitting binary data? So whenever we are talking about most common or simplest form is on-off keying, ASK, on-off keying, or we can say ASK. Which component is involved in conversion of a input radio frequency signal into intermediate frequency signal at a super heterodyne receiver? When you go for super heterodyne receiver, first we receive the signal, then we are having a you can say RF amplifier. After that we are having a mixer. Mixer will convert the incoming signal into the intermediate frequency, and mixer at the input of the mixer, you can say the incoming channel, and we are having the local oscillator from the downward side. So that will be a mixer. Yeah. How does impedance transformation in an AC circuit enhance power transfer? Right. So to transfer the maximum power, what should you do? The source resistance should be aligned with the load resistance. So enable maximum power transfer by aligning the source and load impedance. Next. What does mutual information signifies between two random variable x and y in context of information theory? So basically, whenever we are talking about mutual information means how much information the two random variable are sharing with each other. That is called as the mutual information, right? So what will be the answer? The amount of information that x and y are sharing with each other. Next thing, the quantization noise in pulse code modulation is mostly affected by which of the following options when the input signal is random process? So basically the quantization noise, how much is the quantization noise? The minimum value is delta by 2 and minus delta by 2 to delta by 2. So that will be the quantization noise. See, the delta is the step size, and the step size will depend on the, you can say, the number of quantization level. So basically your quantization error will directly depend on the what? Quantization level. As you increase the quantization level, the quantization noise will decrease. So answer will be number of quantization level. When a clock minute hand move, its shaft twists slightly, okay, generating a torque proportional to the angle of twist, correct? Which physical property determine the torque in the clock? See, that is torsional stiffness of the shaft will define that. In a system with a negative feedback loop, how does the overall gain behave when the gain of feedback path is positive? The overall gain will increase, right? Whenever you are having a negative feedback loop, okay, negative feedback loop. 1 second. This is Z and this is H here. So this is plus and negative. H is here. What he says, the overall gain behave when the gain of feedback path is positive. When this gain is feedback path is positive, then G upon 1 plus GH. So the gain should be decreased. Answer should be B, not A. In an electric motor, the input is an electric signal, okay, and the output is mechanical motion. What does the transfer function? The transfer function is always defined as the Laplace transform of output divided by Laplace transform of input. So what we can say? It is the ratio of electrical input to the mechanical output, right? Output upon input. Answer should be B, not A. That should be B. Basically, what you can say, the Laplace transform of output. Output is a mechanical motion, right? Mechanical output, and input is a electrical signal, electrical input. The answer will be B, not A. This answer should be B. Yeah, answer is not written correctly, but explanation is correct. In a control system, a summing point with two input A and B produce the output Y. What is the output of the summing point if both the input A or B are positive? Then that will be the sum of A and B, right? It's just a simple question. You are having a summing point here, you are having a input A and B. So what will be the output of this one? A plus B. This paper is the easy paper if we are talking about. How many forward paths are there? See, forward path means from the input to the output. So first forward path is this, and another forward path is this. Yeah, this should be arrow in this direction, like this. So there are two forward paths inside this one. A proportional control system is used to regulate the temperature of a heater by adjusting the on-off cycle time. What is the main feature of proportional controller in temperature regulation? Okay, so basically whenever we are talking about proportional controller to regulate the temperature, by adjusting the heating time based on the difference between the current temperature and the set temperature. As the temperature approaches to the set point, controller reduce the heating time, and if the you can say the temperature is going away, it will increase the heating time. So right, so it will be the depending on the temperature difference. So let's check the answers. It keep the heater on constantly, no. It reduce the power supply once the temperature reaches to the set point. That will be the answer. It only work when the temperature is below the set point. It increase the power supply after reaching the fixed point, no. It will reduce. While analyzing the stability of a control system using Raoult-Hurwitz criteria, what does the sign change in the first column of the Raoult table? Raoult table, the root of closed loop right half plane, correct. So basically whenever in the first column, if sign is changing, it show you that the one root or and in the number of times the sign change in the first column, that much amount of poles are lying in the right half of S plane. A Nyquist plot of the system does not encircle the point -1 J0, and there is no pole of open loop transfer function in the right half of S plane. What you conclude about the stability? That system is stable, right? If you are having no pole on the open loop pole on the right half and you are not encircling the -1 J0 point, it means your system is stable system, because there is a formula n is equals to P minus Z using that one. Okay, what does the Bode plot of a system represent? where h of omega is the system frequency response. That will be the phase and the magnitude plot, right? Magnitude and the phase plot of Hj omega. If P is the number of poles, that is the number of zeros of open loop zeros, what does the number of roots of a branch when P is equals to Z? So that means all the okay, he is talking about the root locus. If P is the number of open loop pole and Z is the number of open loop zero, what is the number of root locus branches if P is equals to Z? The all root locus branches originate from the finite open loop pole and terminate at finite open loop zero. No branch will go to the infinity whenever you are having P is equals to Z. See, this is the just basic question from the root locus. What you are seeing till now, we are seeing that all the questions from the basic. If you know the basic thing about any plot and anything, you can tackle these questions. They are not asking that depth, you have to go in all inside that depth, right? For a LTI system with impulse response ST, what does the output become when the input is unit step? That is called as step response, or you can say that will be the convolution of ST with the unit step, because whenever you are having a system having ST and XT is here, then output will be YT, that will be the convolution. YT is the convolution of ST with XT and XT is UT, so what we can say, this convolution of ST with unit step signal. A robotic arm use PID controller to maintain a precise position despite external disturbance. How will the motor adjust the input based on PID controller? See, basically by adjusting the input proportional, integral past error and predicting future error. That will be the answer for this one. Okay, next. An electric circuit consists of two capacitor and one inductor. How many state variable? The number of state variable is always equals to the number of energy storage element inside that circuit. So basically what we can say, if you are having two capacitors and one inductor, so we are having three energy storage element. So what we can say, there are three variables are required for that purpose. A PI controller is implemented in a system with unity negative feedback. Okay, what is the primary role of integral action? The integral action is generally reduce the steady state error for that one. In a lag compensator circuit, the output voltage is determined by the current flowing through the series connection of resistor and a capacitor. What is the primary role of a capacitor in lag compensator? That will be decreasing the settling time. In amplitude shift keying, we are talking about ASK, amplitude shift keying. How is the logic 1 typically represented in binary ASK? We are generally associate, when we are talking about the one, we are giving a amplitude, means we are giving a value like 5 volt, 6 volt to that one and 0 volt to 0. So generally combine the multiple frequency, no, 90-degree phase shift, no. So assigning a specific frequency, that is FSK, associate a certain amplitude to the carrier wave. Okay, a radar system sends out a specific signal to detect an object in an environment. The received signal is noisy and the system uses match filter to identify the object by maximizing the signal to noise ratio. So what is the primary function in the radar system? To maximize the signal to ratio for accurately detection in the noisy environment, right? That will be the use of match filter. See, already given the answer here. You can just check that which paragraph is matching to that one. Which method is mostly accurate for analyzing the error performance of a wireless network in a multipath fading area? The needed error performance, that will be done by the Monte Carlo simulation. This is the Monte Carlo simulation is generally used for wireless communication. Which of the following is the step involving to encode a message using Hamming code? That will be calculating the number of redundant bit. A time division multiplexing system where user are assigned a specific time slot to transmit, the system operates under centralized control, where the control node synchronize the time slot of each user. Why TDM required a guard time between transmitting user? So to prevent overlapping of user transmission due to phase difference using guard band, right? That will be the answer. Which principle is responsible to ensure that quantum information is secured from unauthorized replication? No cloning theorem. See, no cloning means we are not making any clone of the masses, so no cloning theorem is used for that purpose. Which feature of Zener diode make it suitable to use a compact circuit and mobile application? See, main feature is effectively it can do the voltage regulation. So answer will be C. The main feature is that. Under which condition does the bipolar BJT operates in saturation region? We already know if your BJT is working in saturation region, both the junctions are forward bias, emitter base and collector base junction should be forward bias. If your BJT is operated in you can say active region, right? In active region it can work as an amplifier, in saturation region it can work as a switch. So if you are talking about the active region, the emitter base junction is forward bias, collector base junction is reverse bias, like that. So basically he is asking about the saturation region when the collector base junction and emitter base junctions are both are forward bias. So answer will be D for this one. Which condition determine the threshold point of for a MOS capacitor? See, that will be a surface electron concentration is less than the bulk doping concentration, right? Answer will be B for this one. What fundamental principle is used to drive the equation for each mass when applying a mass analysis to determine the current in a circuit? So basically whenever you are applying the mass analysis, where we use the KVL, if you are applying the KVL, yeah, in mass analysis we are using the Kirchhoff's voltage law, and in nodal analysis we are using the KCL. So answer will be A. Which operating region bipolar fully on and work effectively as a switch? That is the saturation region. Answer will be C for this one. Which of the following describe the optical property of a photodiode? See, it measures the sensitivity of the light. That is the main optical property. If you incident the light on a photodiode, so there will be light incident on the junction. There will be your photodiode is reverse bias, large number of light incident on the junction, and there will be large number of electrons and hole pair are generated, and that will be the current will flow. So that will be it is sensitive to the light. So it measure of the sensitivity to light. Which type of sample and hold circuit is specifically designed for application like analog to digital converter, where precise timing is crucial and accurate signal processing? The pulse sample hold circuit will be used for that purpose. In which operating region does the bipolar junction transistor function effectively as an amplifier? So in generally if you are talking about the BJT as an amplifier, so BJT will be work as an amplifier in a active region, right? I already discussed this. Which type of memory is best suitable for digital electronics application where high storage capacity is required at low cost? Generally we are using dynamic random access memory for that purpose, DRAM. What term refers to the duration a microprocessor takes to access the memory or I/O device and complete the associated read and write operation during the process? That is called as machine cycle, right? There are several cycles: machine cycle, fetch cycle, execution cycle, right? Like that. So this one is called as machine cycle. Which controller is specifically developed for interfacing the keyboard and display device with 8085. It is Intel 8279. This is the controller which is used to connect the keyboard and display devices with 8085. Okay, which reset mechanism is designed to activate when a supply voltage drop below a predefined threshold voltage, that is called as brownout rest, right? That is called as brownout rest. Which mode of operation does the configurable logic block, right, produce two independent function, each involve fold variable, that is FG mode, right? This is called as FG mode. Which force is experienced by a hole present under the oxide layer when a positive gate voltage is applied to the semiconductor surface? So whenever you are applying a positive voltage on the semiconductor, this is the oxide layer here, and here is a hole, right? Hole, here is the hole, and this is your gate. If you apply a gate as a positive voltage, right, hole is also having positive charge, so positive will repel each other, that is a repulsive force. In the node analysis method, which recommended characteristic a reference node? See, we generally choose a reference node which is having a zero potential or ground potential, right? We should connect to the ground or zero potential to calculate the other voltages with respect to that one. A superposition theorem is particularly useful in which of the following type of circuit? See, superposition theorem is generally used whenever you are having a multi-source network, or you can say a complex network. So we can easily solve using the superposition theorem a complex circuit with multiple independent sources. What does the pointing vector represent in electromagnetic theorem? How the direction is determining, right? So basically, whenever we are talking about the pointing vector represents the energy flow per unit area, and its direction is perpendicular both electric field and the magnetic field. So which will be the answer? Answer will be C for this one. How does the current through a capacitor behave in DC circuit when the circuit is reached to steady state? Whenever your circuit is reached to steady state, capacitor will behave as a open circuit for that one, right? Your capacitor will behave as a open circuit, so it means your current is become zero in that circuit. So answer will be C. Okay, for a resistive circuit, Yt is equals to B times Ft, what condition ensure that the circuit is time invariant? Whenever you are having a resistive circuit, it means this is a function of time, this is a function of time, right? This is input, this is output. So this should be not a function of time. If you want to make that circuit time invariant, which will not change with time, so what we can say, B must be a constant, not a function of time. It should be a constant. What is the resonance condition in series RLC circuit when analyzing in the frequency domain? So whenever you are analyzing a RLC circuit, and that RLC circuit is working in, you can say, at resonance condition, at resonance, what happen? XL is equals to XC, right? It means your capacitive reactance is equals to inductive reactance. So what will be the answer? Inductive reactance equals to the capacitive reactance. For an amplifier characterized by H parameter equivalent circuit, the voltage gain is influenced. See, basically whenever we are talking about the voltage gain, that will be the voltage gain of the amplifier. It will depend all the four parameters, right? H1, H2, all the four parameters. So all four H parameters. What happened to the Fourier series representation if the period t of a function approaches to infinity? So whenever your t tends to infinity, your period tends to infinity, that means you are going towards a aperiodic signal, and aperiodic signal, your Fourier series will be converted into Fourier transform. So what will be the answer? Answer will be Fourier series become Fourier transform. What is the relationship between the impulse response h of n and its frequency response? So basically, h of n, if you take the dtft of h of n, that will be converted h of e raised to the power j omega. The frequency response is dtft of the impulse response. Impulse response is inverse dtft of frequency response. Both the answers are correct. The impulse response is equals to the frequency. That's not correct. Impulse response is Fourier series of frequency response. No. This one is also correct. This one is also correct. So what is the relationship between impulse response of a system and its frequency response? So the impulse response is inverse dtft of frequency response. I think it should be is I dtft here. That's why the answer will be B. Right? Inverse dtft of impulse response. I think so. That is written in the question, that is misprinted here, right? Which of the following represents the region of convergence of a causal sequence in Z domain? So whenever you are having a causal sequence inside, in case of causal sequence, your ROC must be ROC must be covering the region outside the outermost pole. So if you are having a outermost pole here, the ROC will be outside of that one. So outside the outermost pole. What happened to the output of a LTI system when the input is delayed by t naught? So if your LTI system linear time invariant, if it means it will be not varying with time. If you delay the input, same amount of delay will be reflected at your output. So output will be delayed by t naught. The multi-stage amplifier, why is the coupling of storage stage is typically done using capacitors? See, to do that, what we are doing, if some DC output, DC you can say the first stage, and if some DC output is coming from the output of the first stage, so we are using a capacitive filter in between them, so that it will block the DC. So it will provide you insulation for the DC. So it blocks the DC component between the stages. Which of the following condition ensure no signal distortion in an LTI system? Whenever a distortionless system is amplitude response is you can say independent of time, and space response is linear function of frequency, not time. The amplitude response is independent of frequency, and its phase response is linear function of frequency. See, if I am talking about group delay is constant, and phase will be linear function of frequency, right? Answer will be A. Which window function is reduce the ripple amplitude if in the frequency response but result in slightly worse cutoff sharpness? That is Hamming window. Hamming window. In a parallel structure of LTI system having transfer function H1s, H2s, whenever you are having parallel system like this, we are having H1s and having H2s here plus, so it will be added together. So with that will be H1 plus H2s. Which law describe the relationship between time varying electric field and magnetic field in free space? That will be Ampere's law. What is the key function of radar system in terms of object detection? See, basically radar, what will radar do? Radar will transmit a signal from transmitter. That signal will reaches to the receiver, and receiver means object. The object which is coming towards us, that will reach to that object will reflect some part of that signal, and the radar will receive back that signal. On the basis of that that received signal, it will identify that which type of object is coming or going away from us, right? So radar transmits an electromagnetic wave and analyze the reflected signal to detect the object. What does impedance matching ensure when a wave travels from one medium to another medium? So whenever your wave is traveling from one medium to the another medium, the impedance matching should be done. Why? So that the maximum power will be transferred from one medium to the other medium. So what will be the answer? The maximum transmission energy across the boundary with minimal reflection. In a simple charge-free medium, what is the relationship between the electric field E, magnetic field H and wave vector K? See, both electric field, magnetic field and wave vectors in EM wave are always perpendicular to each other, right? So both means E, H and E, H are both perpendicular to K, right? And also E and H are also perpendicular to each other. Which property of transmission line helps in minimizing signal loss during the power transfer? That is proper impedance matching. Impedance matching, see 3 to 4 questions from the impedance matching. That will be impedance matching. How does the Smith chart simplify the impedance matching in the transmission line? By graphically representing the reflection coefficient and normalized impedance. See, we are doing the graphically representation of the reflection coefficient and you can say the normalized impedance inside the you can say the Smith chart. Which mode is supported in coaxial cable but not in the rectangular waveguide? See, that is TEM mode. TEM mode generally supported by coaxial cable, but your waveguide will not, means the rectangular waveguide will not support that TEM mode. So which mode is transverse electromagnetic mode? Coaxial cable, right, it will support that. Which antenna type is primarily used for high gain applications such as satellite communication, radar system offering a narrow beam width? That is a parabolic antenna. We generally see that all satellite transmission, radar and everything will be done by this parabolic antenna, right? Why? Because it's offering a high gain and you can say within narrow beam width in a particular region. What is the effect of using an antenna array with multiple element on the overall beam width? See, basically whenever you are having a antenna array, so multiple element narrow the beam width and increase the directivity so that your antenna will transmit most of the power in a particular direction. Which radar system is primarily used to detecting the moving object by measuring the frequency shift? That is Doppler radar. Doppler radar is based on the frequency shift. What is the mechanism ensure that the light signal will transmitted confined to the core of the optical fiber? So basically whenever we are talking about optical fiber has two things, core and cladding, and your wave is traveling inside the core. Why this wave, the light wave is only travel through that core? The reason behind that is total internal reflection, right? The total internal reflection within the core. So these are all the questions. So basically these are the very easy questions. If you want to prepare for that one, I think it's best opportunity for you. You are from the electronics, you already see the level of the questions. Some questions you can say that are we are not generally studied, but all of the questions are from the basics of your electronics. So if you want to prepare for that one, this is the best opportunity. 179 or 175 approx vacancies are already declared by the BEL for the electronics candidate, and these days the competition in electronics, you know, very less. The students are not adopting the electronics branches in their colleges. So what we can say here, this is the best opportunity for all of you. If you want to prepare, go for this one. Paper level is not that much hard, right? It's easy, but there are several topics which you don't cover in your GATE exam. I'm again saying that thing because if you are preparing for GATE, right, and you are thinking that you can easily crack this exam, it's not possible. That's totally different from the GATE. You can see several topics are there which are not, we are not covering inside the GATE. So if you want to prepare for that one, you dedicatedly give 1 or 2 hours every day for this BEL along with your GATE preparation, and it's a easy exam, and you can say you will be selected in BEL. That is a very good opportunity, or very you can assume that your career will be going in a very good direction after joining the BEL, right? So basically for that one we are already launching the we are going to launch the live classes, right? That will be started from 1st of November. If you want to prepare for this BEL exam, right, and really want a good career in your future, so you should prepare for this BEL exam and you can join Yourpedia Education. We are going to start the live classes from 1st of November, which are dedicated to dedicatedly for BEL, where we are providing only that content which are necessary for this BEL. We are not providing you extra things that you should study this one and that one. What we have, we analyze from the previous exams. I will come one more or two more exams from this BEL, right? And you will understand that the level of BEL is not that much, but the things which should you cover, that should be very vast. So basically if you want to prepare for that one, you can join Yourpedia, and live classes are going to start from 1st of November. So see you in the class. Bye bye. And I think these solutions will boost up your confidence that you can do for BEL. Thank you.